Question 6 is a calculus question, and it never uses the word differentiation. I mean, when you get to part B, obviously they've got the second differential notation there. But as soon as they're talking about things about minimizing or minimum costs, it's either, if it's a quadratic, it may be to do with the vertex, but if it's any other type of function, as this is, it's going to be to do with differentiating. So, what do I need to do? Well, I need to differentiate C. So, before I can do that, I just need to rewrite it as powers. So just be really careful. That first term, so the 1,500 won't change. That's 1 over v, so that's going to be v to the minus 1. For the second term, it's only the coefficient that's a fraction. So I don't need to do anything there. That's just a term in v. So I am going to differentiate that. So obviously we normally use dy dx, but this function is c in terms of v, so it's going to be dc dv. So I'm going to multiply by the power, and I'm going to reduce the power by 1. For a v term, I'm just going to differentiate that to 2 over 11, and the 60 is going to differentiate to nothing. So that earns you 2 marks for your differentiation. When we're talking about maximizing or minimizing, we're talking about the differential equaling 0. Okay, and then I've just got to think about how to deal with that v to the minus 2. So my preferred, well, I've lost a minus there, haven't I? Let's not do that. So my preferred method is to rewrite the v to the power of minus 2 as over v squared, because that's what the power of minus 2 means. Then I think for this one, let's give myself a little bit more space, I would add the minus 1,500 over v squared over to the left-hand side. I would multiply up by the v squared. And then I need to do 1,500 divided by 2 over 11, or times by 11 over 2. So that gives me v squared of 8250. So v is the square root of that, which works out as, and v is the value in this case, so a negative root is not going to make any sense. We can ignore the negative square root. Oh, sorry, ignore me. It's not a value, is it? That's for part 2. It's a velocity, but they're always carrying on the same direction. So 90.8, and the units for that are kilometers per hour. Okay, and I don't need to prove that that's a minimum. It will ask you separately if you need to do that, and that's what it does in part B. Okay, so that's absolutely fine to just at this point assume that that's going to minimize the cost. It doesn't actually ask me for that minimum cost, so that's fine. I'm just going to go back to, might do that working up here. So the actual minimum cost, I'm going to go back to this equation, so 1,500 over the answer I've just found for v. So I've calculated that v is 90.8 plus 2 over 11 times 90.8. So just never put stuff straight into your calculator, just in case something goes wrong. Get the working written down, and then any answer which rounds to £93 is acceptable there. Okay, so then it does ask me to prove that that's a minimum, and quite a nice question, because they remind me that to do that I need the second differential. So let's do that here. Okay, so I've got the first differential there. So what am I on now? So for part B, the second differential, let's just differentiate this again. So I'm going to multiply by the negative 2, that'll make it positive 3,000, and reduce the power by 1, and the 2/11ths will just differentiate to 0. I'm going to substitute in my value for V, which was 90.8. And then it's just being very careful to clearly conclude what we're showing here. So 300 over 90.8 cubed. And although we're not really bothered about what the actual value is, I would still write it down because it's just evidence that you've done the calculation. But what we really care about is that that is greater than 0. So as the second differential is greater than 0, that tells us it's a minimum point. Okay, and then part C, state one limitation of this model. So for this type of question, obviously you can't really prepare for these because you don't know what type of situation they're going to describe. So you just need to look at what they've told you and think about, you know, what doesn't make sense. And this whole model, I mean, it says it in the first line of the question. This model is based on the premise the second line of the question, that the lorry is driven at a steady speed. So its speed throughout its entire journey is v kilometers per hour. So when you think about it, that is very, very much not a sensible assumption to make. So the speed, I'll put is unlikely. I think we could probably put is impossible, but let's be, in fact, no, I think it is more than unlikely, isn't it? So the speed, how can we phrase this? So the speed cannot be the same for the entire journey, and then just try and give a reason for why. So speed cannot be the same for the entire journey due to, and I mean, what is going to affect the speed? Well, traffic lights, traffic, I mean, there's so much roadworks, different speed limits on different roads. You don't need to list every single possibility, but that's really the key thing why, having done all that maths, we can then conclude that this model probably isn't really that great.